turned to page 88, I'm sure. Oh, let me just make one comment about the videos. I know up until this point, a lot of it's been super easy, and you probably didn't need to watch the videos. However, what you need to remember is that that is your second day of school. You're not getting the 2 days in person. So you're in person on Wednesdays, and I put those videos up. I told my 8th grade grammar class that it's not because I don't have anything else to do on Saturdays and I just love to go in my basement and make 6 videos. That's not the case. I don't mind making them, and I do want to make them for you. But as we get further in, and I would say that we're kind of rounding that corner, you do need to watch them. And I can see if you have watched them. And so there may be times where I say this video is mandatory and you're going to get a participation grade for it. So you need to go in and watch it, and then I'll be able to see, and you'll get the grade for it. Yes?
Why do I need to watch a video if I understand it perfectly without it?
Okay, you didn't let me finish. The second option, and I gave this to my grammar and writing class, is that your mom clarifies with me that you do understand the material, or she's gone over it with you. So some of you maybe fall asleep with videos. Your mom just needs to clarify with you, okay, let me make sure you understand this. So I just need the clarification. If I put something like that on the house that says, Moses, this is mandatory, please watch the video. There could also be examples that I do in the videos that I want you to do and turn back in for me. So, again, I'll warn you. I won't just surprise you. I'll say there's some things in the video that you need to do to turn into me. But that will come in a warning in the has. So I do understand that sometimes it's very, you look at it and it's super easy to understand. But then there's sometimes where I do want to explain things to you. All right, so let's take a look at 2.6, and we'll finish out the class period with this. And this has lots of little things that you're going to have to do index cards for. And there's a couple things here. The first thing is reflexive property. Now look at the top and you'll see these cute little couples or a couple of people standing there together. Reflexive property means that AB equals AB. Now if I get 2 yardsticks out and I hold them up, yardstick 1 equals yardstick 2. Reflexive property. Here these guys are probably, if Jean is the same height as Jean. Of course that makes sense. It's almost like looking in a mirror. So I could say Kezzy is looking in the mirror. Kezzy is Kezzy. Kezzy equals Kezzy. It's reflexive, like reflecting in the mirror. So AB equals AB. Angle A equals angle A. There is congruent to angle A. Symmetric property is a little bit different. It's not 2 Kezzys or 2 Jeans or 2 Joels. It is 2 different people. And there's symmetry there. So we have in our little example, the symmetric property, Jean is the same height as, or if Jean is the same height as Pedro, then Pedro is the same height as Jean. Now let me go back to the yardstick example. If this yardstick, 36 inches, is the same length as this piece of wood, we'll call it Fred. Fred is the piece of wood. Thank you. Then the piece of wood equals the length of the yardstick. And the piece of wood could be a yardstick if I wanted to cut it out. So that means, the first one is that you're looking in the mirror. Johnny's looking in the mirror. Johnny equals Johnny, right? Maddie equals Maddie. Ashley equals Ashley. You're looking in the mirror. That's reflexive. But the symmetry is, if I got Maddie and Ashley, are you guys the same height? No? Okay. I don't notice those things. But if I got 2 people up here that were the same height, let's say we were talking about Abel and Jordan Mills a minute ago. They're really tall. And if I got them up here and they were the same height, then I could say Abel equals Jordan, 2 different people. That's the symmetric property. Finally, the transitive property allows us to then apply it to other situations. If Jean is the same height as Pedro, and Pedro is the same height as Chris, then what can I conclude? Yeah, all of them are the same height. So if I said Abel is the same height as Jordan, Jordan is the same height as his father, what could I conclude? That Abel and Jordan's dad are the same height. So now I can start making some conclusions. So you need to include those in your index card and make sure that you remember those things, because they're going to pop up. They're going to be the reasons that you can use to prove your statements. Now, in just a second, we're going to go down and we're going to do our first little proof. But up here in example 1, you have to name these different properties. So we have reflexive. Remember, that's me looking in the mirror. Mrs. Jernigan equals Mrs. Jernigan. Don't you wish there were 2 of me? Because then I could just teach you all your classes and we would have so much fun. Why aren't you guys jumping up and down? Thank you, Josh. But then the symmetric is like when I put Abel and Jordan next to each other. And then finally the transitive is when I make an assumption that Jordan's dad is the same height. So let's take a look at these examples. If GH is congruent to JK, then JK is congruent to GH. Which property is that? And you just have to, they break it into, all I want to know is symmetric, reflexive, or transitive. I don't want congruence or equality. Which one is that? GH, let's assume GH is Abel. JK is Jordan. If Abel is equal to Jordan, then Jordan is equal to Abel. Which one is it? The symmetric. All right, the next one. DE equals DE. Which one is that? Amelia. The reflexive. Look in the mirror. Mrs. Jernigan equals Mrs. Jernigan. If angle P is congruent to angle Q, and angle Q is congruent to angle R, then angle P is congruent to angle R. Which one is that, Moses? Yeah, and that trans word. Remember, if you have a transitive verb, there's action that's being moved to someone else. It's the same thing with a transitive property. It's like we can move this conclusion to someone else that maybe isn't in the room. All right, I want to introduce you and this is a super simple little proof, but of what writing proofs will look like. In every proof, there's going to be a little description or some instructions. So it says here, in the diagram, N is the midpoint of segment MP, and P is the midpoint of segment NQ. And they want you to show that MN is equal to PQ. Now you can't just say true. It's not a true-false quiz. You can't just say true. What you have to do is write out steps. So we're going to write out the steps. And this is the way I like you to write them. And you could write here, I've used different words here, process, step, whatever. But then this is your reason. So remember when I talked about the eggs, the flour, the salt, you had to have all the reasons why those had to go in. So what we're going to do, they don't necessarily give you a little chart yet. I don't know when they start doing that. But it says, in the diagram, N is the midpoint of MP. And P is the midpoint of NQ. Show that MN equals PQ. So what we're going to do first is we've got to come up with a first step. And the first step that they come up with is that MN equals NP. So here's, and you need to number them. MN, and maybe it would be helpful if I had this drawn on here. All right, we have N, which is right about here, and P, which is right about here. and M and O. Okay. I have 4 different segments here. What are the 4 segments I have? Who can tell me the 4 segments I have? Elizabeth. O. There's one more. MO, yes. Sorry, let me just turn that off. Okay, so I have 4 segments. Now what I want to be working toward, it says it wants us to show that MN equals PQ. Let me give you a clue here. The very last thing that says what they want you to prove, you're going to put at the end. And you don't know what number it's going to be. But I'm going to put that at the end because I know that that needs to be my end statement. MN equals PQ. That's my end statement. It might be 3 or 4. I'll put a 3 there. That's the end. Whatever they tell you in that statement, that's what you put at the end. That's where you've got to get there. Now what I need to do is, what I want to go through is look at the diagram and see how I can get to that point. Oh, maybe this is supposed to be a Q, right? Sorry, I thought it was an O. Yes? It should be N, yes. Sorry, let me just make sure that is, yeah. So they give me a couple of things. The only thing they give me is that N is the midpoint. What is N the midpoint of? MP. And since this is the midpoint, I like to draw on my things. What do I know? If I know the midpoint formula, theorem, whatever it is. What do I know if something's the midpoint? Yeah, so these are equal. Are a little congruent. So we know that those are equal because that's the midpoint. And they told us that in the very beginning. So you've kind of got to diagnose and look through and figure out, what clues they're giving you. The next one, let's see, and P is the midpoint of NQ. So here's P, another midpoint, which means that this one's going to equal also. So we know a lot of things just from the diagram. It's like your little detectives. So the first thing they say is MN equals NP. What is our reason for MN equal NP? Johnny, do you know? Huh? Come on, come back with us. You're falling asleep. Geometry's so exciting. Why can MN equal NP? We didn't get a ruler out and measure it. We can only go on the information. But why can it legally? Joel.
Dump those 2 lines in the middle, simulate that all those are equal. All those segments are equal. Right?
The midpoint?
Yeah.
Assumption? So yes, if something is the midpoint, we know things on both sides are equal. So all you write is midpoint, or midpoint, I think it's a definition, midpoint definition. All right, so we've got our first reason, and it's because the midpoint definition. Now, we didn't just learn about the midpoint definition. Where do we find the midpoint definition? In our index cards from one of the previous chapters we've used. So you've got to reach all the way back to the stuff you've already done. Now we're going to do NP equals PQ. And it would be the same reason. So I'm just going to do those little quote marks, same reason. Now, can I say that MN equals PQ? Legally? Can I say it? Everybody's shaking their head. Well, let's take a look. MN equals NP. Oh, here's NP again. NP equals PQ. Well, now I can say that these two are equal, but what's my reason? Your reason will be something from this chapter, yes. Transitive. So you're going to write in there the transitive property. because we didn't just have two MNs. That would be reflexive. We didn't have MN equals just NP. No, it went further than that. We were able to transfer it to that other one. All right, so that's a proof. That's how you do a proof. You set up a chart. You have your steps. You write down, if on a test I give you a proof, and you don't have a chart set up, and you don't have the last thing entered, you want to put, because whatever they ask you to find out goes in here. I will be so upset I will probably cry if you don't at least do that. I'll even give you points for doing that part. Okay? So this is how you set up a proof. Now there's probably a couple of little ones that are going to pop up in homework. And we haven't even gotten to, I want you to look at page 90. There's 5 more properties you need to add to your index cards, but they're super easy. You learned them in algebra. The addition property, doing the same thing on both sides. Remember that in algebra? If you do it on one side of the equation, you have to do it on the other. Same thing for subtraction, multiplication, division, and substitution. So make sure that you write those down in your index cards and do your best on the proofs. We'll do some of them in class next week. Okay? Hopefully you guys understand this, but start watching the videos because I will be doing practice with these.